Well, hello everybody, prynhawn da, good afternoon. Really good to know that so many of you have come here this afternoon. A very warm welcome. Croeso cynnes I chi gyd. A gobeithio yn wir newch chi fwynhau y sgwrs gyda'r cwmni heddiw. So this afternoon is an opportunity to get to know three scientists, women who are leaving a lasting legacy at the top of their game, and of course recipients of the Frances Hoggan Medal, given annually by the Learned Society of Wales. Rhowch groeso felly i'r tair, please welcome astrophysicist Professor Haley Gomez, glaciologist Professor Tavi Murray, and biochemist Professor Dame Jean Thomas. Now, normally, if we were all together in the same room, that would have resulted in an applause. And we're very thankful for this technology that enables us to do this kind of thing, but it isn't the same. Not being able to see you or hear your reactions or feel your warmth and appreciation. So what you're doing in essence, I guess, is eavesdropping on a conversation between us. There is a short Q&A at the end, so feel free to ask a question in the box at the bottom of your page. My name is Elin Rhys, and it really is a big deal for me to chair this conversation today. About 40 years ago, I used to call myself a biochemist, and now I can only dream about it, and broadcasting has been my career. Today is not about an in-depth look at the research of our three scientists. You can download their papers on the web if you want to, but what you won't get there is a chance to get to know what drives the scientists to do the work that they do, how they got there, how they feel. And I remember interviewing a scientist once in a conference and saying, well, so how do you feel about this? Only to hear her say, look, I'm a scientist, I don't do feelings. But I am hoping that our guests will reveal what their research has meant to them, the challenges, the pitfalls, the sort of moments of madness, what personality traits that they have that enables them to succeed, and what messages, more importantly, they might like to pass on to the next generation of women in science. So let's face it, Dr. Frances Hoggan, born in Brecon in 1843, qualified as a physician in an era when women just weren't allowed to do things like that. She had to go as far as Zurich in order to get herself qualified, the only place where it could happen. And indeed, she was only the second woman in Europe to gain a medical doctorate. But she was determined to support women in science and in medicine, pushing for a better education for girls. So there have been 5 recipients of this award so far, and we have 3 of them with us today. So to start off, just for a warm-up, I'm going to ask each one of them to briefly describe the area of research that they are in. So starting with the most recent recipient in 2020 and in lockdown, and in fact somebody who just got the medal in the post today, Professor Haley Gomez. Could you tell me a little bit about what you do?
Yeah, sure. Thank you for that. I'm really interested in finding out the origins of cosmic dust in the universe. So cosmic dust is just small particles in space, fills a lot of the space between the stars, which is a real nuisance because it really affects out the way we view the universe. But more importantly than that, cosmic dust is the building blocks for planets like our Earth and also for life itself. And we still don't know where it's made. Or even when in the universe history we first saw dust being produced. So I use space telescopes to try and see this invisible dust, we like to think of it as, but it's not invisible at infrared lights. And I use that to try and pin down where dust is formed and where planets come from.
Brilliant, thank you. And just before we move on, can you show us the medal? Have you got it handy? There you go, Professor, the medal.
And I'm very, very happy because my husband has a medal from the Institute of Physics and mine finally came today. So I can say, look, I got one too.
Excellent. Thank you, Haley. So Professor Tavi Murray then, I think it was 2019. I bet you don't, do you know where your medal is at the moment?
Oh yes, but sorry, it's not on my desk at the moment, sorry.
So can you describe your work, Tavi?
Sure, yes. So I'm interested in the stability of glaciers and ice sheets. So I'm particularly interested in the bits that move fast. Most people sort of think of glacial ice as being the slowest thing moving ever. You know, you talk about moving glacially slowly and thinking about something creeping along. And that's true, but some parts of glaciers and ice sheets move much, much faster, a metre a day, or even up to 20 to 30 metres per day. So you could sit down, eat your lunch, and actually watch them move. And it's those parts, because those are the parts that control the stability of ice sheets and glaciers. And so I'm interested in the contribution of the big ice sheets and glaciers to sea level, how much sea level rise we're going to have. But that gives me particular interest on what happens at the bottom of the glaciers and ice sheets, because that's where the fast flow all is facilitated. And then also how they interact with the ocean, so iceberg carving and melting at the front of tidewater glaciers. So that's me.
Lovely, Tavi, thank you. So Professor Dame Jean Thomas, you were the very first, you were the inaugural recipient of the award. So could you describe your field of research?
Yes, thank you, Elin. Well, in all our cells in our body, there's 2 meters of DNA, and that DNA is packaged into a thing the size of a spot, or less than the size of a spot on a printed page. So since 1974, I've been interested in the way in which DNA is packaged by proteins, a particular class of proteins called histones, to give them material that we call chromatin, which is the form in which DNA occurs in the cell. And also in how this structure is modulated by other proteins that interact with it, either tightening it up, making the DNA less accessible, the information less accessible to be expressed, or loosening it and making the DNA more accessible. And I've also spent quite a bit of time studying the proteins themselves, the structures, using biophysical techniques, NMR spectroscopy mainly. So that's roughly what I do.
Thanks to the three of you, and I think that was a real lesson on how to convey really complex issues and the work that you do in a way that everybody can understand. So diolch yn fawr for that. And what's interesting is that one of you is looking at the infinitely far away, and the other one is looking at the infinitely tiny things that make us up. And the other one is somewhere in between, looking at the very future of the planet in some ways. So it's an interesting choice of three people, three scientists here today. So looking again back at Frances Hoggan, she really believed in education for girls. It was a big thing for her. And in 1882, she even wrote a book, Education for Girls in Wales. So can we look back at your early days then and your inspirations? Tavi, perhaps starting with you. You were in school in Twickenham. What were the inspirations you think that led you towards science?
Well, I think it was a series of things. I think I was extremely lucky to have the doc teach me chemistry at my comprehensive school. The doc was a woman, the only PhD holding teacher in the school, a woman, and that was extraordinarily, I guess, inspirational just there. Suddenly to be exposed to somebody who was clearly a research scientist. So, that was an early influence. But I also told you in conversation with you before this that my family were really inspirational. And I grew up with a great aunt who worked at the Natural History Museum on, we worked out the name of the book that she wrote on fleas, ticks and cuckoos.
Yes.
So she was actually an explorer, and she would go off and make collections for the Natural History Museum and bring back unusual bird parasites for the collections there. And I went as a very small child to the parts of the museum that you weren't allowed to go to if you're just a member of the general public. So that was really amazing inspiration as well. And
if you also told me that you were quite bookish, because you told me a story about how, a little mishap while walking.
Yeah, I mean, I was really bookish, and I would go down to the library, walk down to the library every weekend on a Saturday and get my 5 books that I was allowed out. and I would take them home, and I'd be reading as I walked home. And the story I told you was that I once apologised to a lamppost as I walked along, and I bumped into what I thought was a person, and I was really embarrassed because I was reading my book and I really wasn't looking where I was going. It was a precursor to people who were on their mobile phones as they were walking, and I bumped into and I apologised, and then realised I was apologising to a lamppost for having walked into it.
So there we go. That says a lot about you, actually, Davy. Thank you very much for that. So, Hayley, you're a Barry Girls Grammar School girl, I believe. So what kind of, school days were yours, and what were your inspirations then?
I guess just like Tavy, it's all about the teachers, really. So for me, it was, I had a very interesting physics teacher at A level. I didn't think they were particularly good teacher, and the class didn't really do very well with this teacher, and he was actually a professor. So I was kind of in awe of this man, but he didn't really teach very well. But what he did do was spot what his students were interested in. So he realized one day in conversation, I was interested in black holes and the center of galaxies, and he gave me a book. And then my maths teacher said, "Oh, I've heard you're interested in space. Look at this book." And my maths teacher gave me a book. And by reading those books, I saw and heard stories that I could only dream about in Barry, right? Going on mountaintops and using telescopes to view the heavens. And it turns out that in one of those books was a story about a woman called Vera Rubin, who is just an inspirational astronomer who died sadly in 2016. And that, just reading her story, reading her fight about how she had to fight to use telescopes, she had to fight to access her supervisor's office. Being a woman, she wasn't allowed in that part of the university. And she had to fight to have toilets installed at the observatory. She was the only female that was there. She was not allowed to do a PhD at Princeton. And it was just this catalogue of fights. And I just thought, wow, I love this woman. I love this story. And the best thing about it was the research she did was so mind-numbingly brilliant. Like, everybody must have thought, why didn't we think of that? That's obvious. That's just so obvious to do what she's done. And she discovered dark matter, something that's much more prevalent in the universe than normal matter. So she's a real icon. But I just want to pick up on comment about libraries. I also spent every week at the library, and I also devoured everything I could read in the library. And it was like a second home to me as a kid, all the way up until I was 20 almost. So yeah, I think libraries are clearly a important part of this getting girls into science, as it were.
And I wonder if Google has actually taken the place of the libraries, or do you think that libraries are still that place of inspiration?
Oh, I think libraries are amazing. I
mean, smell
certainly my kids, who are only 3, and they love the library. They love being there.
One thing, Hayley, you told me was that you actually had to change schools, didn't you? Because it was from girls' school, and then you couldn't do your physics A-level in the girls' school.
Yeah, despite having a fantastic physics teacher who was female, she was just brilliant. At GCSE level, as soon as I wanted to go and do physics at A level, they said, well, we only do that at the boys' school because the girls don't really take it up. So I had to go to a boys' school, and I was one of about 10 female students in a school of 1,500 boys. It was an absolute nightmare, but in the way, it paved the way to getting these teachers who noticed my interests and really kind of got me going on that field of astronomy. Before that, I didn't know what I wanted to do. I didn't think I was going to go to university even. Nobody in my family had, so why would I? But those teachers really, going to the boys' school meant that I got where I was meant to be, if that makes sense.
Yeah, so despite him being not a good teacher, he actually did change your life.
Yes, absolutely.
Okie dokes, thank you. Now, Seb, Professor Dame Jean Thomas, Swansea, born in Treborth. What was life like in Treborth, and what was school days like? And what do you think started you off on your path?
Well, I was an avid reader as well. Apparently, I read everything. Even my mother used to say, even sauce bottle labels. I remember in my junior school was Turdinau School outside Swansea, And it was a village school, basically. Both was a village then. Now it's part of the urban sprawl of Swansea. And I remember there was a big cupboard in one of the classrooms, and this was essentially the library. There were just books in it, loads of books, and you could take what you wanted to read. And there was no sort of signing out, no official library. I remember taking, must have been very early on, The Cloister on the Hearth, which is a ridiculous book for a child to read, really. But I remember reading it and enjoying it. And it was only when I read it years later that I just wondered what I'd made of it at the time. But it's a fascinating story. It's about the journey in the 15th century of Erasmus's parents. But there were things like that in the cupboard. You could just pick and choose what you wanted. I started collecting fossils. I hadn't heard of the word science. My parents didn't go to university either. I was like Haley as the first in the family, but that's not that unusual. I used to collect fossils. Of course, South Wales is wonderful. There's coal deposits and limestone cliffs. And I had them in shoeboxes under my bed on cotton wool. It was lovely. Then I did the 11 plus, as one did in those days, and went to a girls' school, Llwynebrin High School for Girls in Swansea. Did my GCSEs. I just loved being at school. I just loved the fact you could learn new things every day. It just seemed like a dream, you know. Everything was new and just knowing new things. I knew I was going to do science in the sixth form, but I also knew I was not going to do biology. So I did physics, chemistry, and maths. And I knew what was coming if I stayed in biology. It was dissection of the dogfish pickled in formalin, and I just didn't have the stomach for that. So I did physics, chemistry, and maths. I thought physics was great. It explained the world around us. I was just amazed that there were laws of physics and that they would explain things, quite common things. And I thought maths was just so elegant. I think I must have been one of the few people who enjoyed applied maths. I thought it explained things, but I thought chemistry was just mind-boggling. Sort of bonding and chemical transformations. I thought there was sort of almost like magic. And I remember, again, at quite an early age, it's a silly thing, but watching yellow sulfur powder and iron filings being heated up over a raging Bunsen burner with the class looking on by one of the teachers, and seeing it turn into iron sulfide, which is a completely new compound, and then learning what had gone on. So things like that had a lasting effect on me. And I left Llwynebrin with my A-levels and a state scholarship in chemistry, and then went on to Swansea to read chemistry.
Chemistry, yeah. So were you aware, because I've often thought of Swansea as, you know, kind of a crucible of science discoveries many years ago, because you've got William Grove and you've got Edward Taffy Bowen, who was kind of brought up the road from you. Were you aware of that scientific essence, something in the air?
No, I wasn't, not at all. It was only later that I discovered that people like Sam Edwards and Diane Edwards and I, for example, grew up within 2 miles of each other. You know, this is 50 years later or something, you discover this. Although not Diane, we had music lessons at the same place on a Saturday morning, piano lessons. But I went to Swansea because it had an excellent reputation for chemistry. And it had a brand new building built in 1961, and I was going there in 1964. And it was in this wonderful location by the sea, with parkland behind. I mean, what is there not to like? You know?
Indeed, what is there not to like?
Yeah.
And I think, thank you, Jean. I think moving on to higher education, as we've actually got there now, Frances Hoggan again was a big advocate of higher education. In fact, she's got this quote, because she studied at a time when the BMA actually stated that higher education was a danger to women's health. You know, it's just mind-boggling. And she said the time was almost passed away for sneering at girls desiring the advantage of higher education. She believed it would mean the difference between a life of monotonous drudgery in an uncongenial home and a life of honourable and useful independence. So how did higher education affect you then? Because Tavi, actually, a bit like Jean, sort of you went to study physics, I believe, and you're not kind of glaciology then, and you were in Aberystwyth. What made you go to Aberystwyth to do that?
Well, I did physics and computer science. I knew as a teenager I wanted to be a theoretical physicist. It's become a bit more practical than that. I've become a geophysicist, so study the physics of the earth, and I do it now in a geography department, but that's just where the UK puts particular kinds of science rather than what the science is. I went to Aberystwyth because I fell in love with it. A bit like Jean Thomas has just said, you know, what is there not to like? I grew up in London. I didn't like living in London. I could get on my bike in London and I could cycle until I was tired, and I was still in the city. I was still surrounded by buildings, and that wasn't really me. I as an early child, in my early childhood, I'd lived by a wood and I'd loved the wood and being there, and we then moved to London. So I was looking for somewhere to do physics and computer science. That cut down the number of universities to choose from, surprisingly. When I went to Aber, I just looked at the sunset over the sea. I looked at the mountains, and I just thought, I want to live here. This is where I want to be. So that's where I went to university. And it was the right subject, you know, and maybe that's not the best way to choose a university in terms of reputation and so on, but it doesn't seem to have done me too much harm to choose a university based on falling in love with the environment.
Absolutely. Yeah, and isn't your family, haven't you got sort of the genes of adventurers in you? Because a lot of your family are adventurers, aren't they? And women, because when you told me that your family believed in girls being educated before the boys, actually.
That's right. I mean, unlike Hayley and Jean, my family does have a tradition of sending people to university, but for 2 generations back from me, the parents believed that the girls must go to university, and the boys, well, they can if they want to, but there's no, you know, they'll do okay whether or not they do. So my great aunt, who, as I said, used to go and collect you know, bird parasites, she had been to university. Her sister had done archaeology at university. My mother went to university and did history, and my aunt actually was a physicist and engineer, and she used to design self-drive tractors when I was a child, and then set up an electronics company that I got my first job as a teenager, you know, helping design circuits to switch buoys on and off and so on for her. So yes, my family believed very, very strongly that women needed to be educated because the world didn't treat them right otherwise, whereas boys, they'd be fine, you know, they'd make a good career whatever happened. So very much in the same tradition, I think.
Yeah, no, thank you. And Hayley, you know, we've already established that it was a not very good teacher that managed to get you on the path, and of course your love of Vera what was it, Vera Rubin
yeah.
inspired you. And you didn't stray far from Barry either, did you?
No, for me, actually, I'm not sure I want to admit this.
Go on.
I hope nobody from Cardiff Uni is listening. For me, I chose the university. I only applied to one on my UCAS form, and it was Cardiff. And it was entirely because I felt like I couldn't afford to go further away. So I had some kind of scholarship from the government at that time. They used to do scholarships for people whose parents weren't in work. But it wasn't enough to pay for rent and so on. So I had a job as well, but I just thought, if I stay in it locally, I can live in my house, catch a train or whatever into the university, live at home. And so I decided on that basis only. I only applied to Cardiff and I got in. And I did work experience at Cardiff as well, the summer before I started as an undergraduate. And I realized how lucky I was to chose to have Cardiff on my doorstep, because, oh my God, the department is incredible. And I remember sitting there listening to a professor who is now working in the US and, you know, was one of the people who helped discover gravitational waves. And I remember listening to him talk, thinking, oh my God, this is where I need to be. This is amazing. And I was just really lucky to chosen my nearest place and it to be so inspiring and so brilliant. And one of the instruments that I used, the Herschel Space Observatory, one of the space missions, part of that was led at Cardiff by Professor Matt Griffin, and I'm just so lucky to have stumbled in there. And I haven't moved. You know, I've spent periods outside of Cardiff for work, but I've always been there since then. So it's interesting because I had an option to move to Santa Barbara, and my husband and I were discussing California on the beach, beautiful, or Cardiff, and we decided Cardiff.
Wow.
Just because of the people in the astronomy department are just wonderful, really, really inspirational. So yeah.
Oh, well, I'm sure they'll be really pleased to hear that if they are listening here today. And Jean, you've talked about, you know, the sort of early days, the new department of chemistry in Swansea, and it's brilliant that chemistry is back in Swansea. But you, while studying chemistry, you then kind of did a sea change, didn't you? Because you left Swansea for Cambridge and you changed subject of a fashion.
Yes, I did. I was perfectly happy being a chemist, and I just assumed I could have always be a chemist. And I was happy with my PhD project and it was going well. But about halfway through, I became aware of all of the work that was going on in what was then a new science of molecular biology. And in particular by the discovery of the determination of the first protein sequence by Fred Sanger. Now, to show that proteins have unique sequences at the time was absolutely a landmark. It cleared up all sorts of other stupid ideas. The first protein structures by Perutz of hemoglobin, which is the oxygen carrying pigment in the blood, and by Kendrew of myoglobin, which is the oxygen carrying pigment in the muscle, and the structure of DNA by Watson and Crick. Now, all of this work had been done in the previous 10 years, and they'd all been rewarded with Nobel Prizes. And when I discovered that all of these people, so I was amazed, scientifically amazed that you could actually do science on huge molecules. I'd only worked on what I thought were big, 14-membered cyclodepsipeptide rings, looking at interactions and things. And I thought they were sort of big. They're bigger than carbon dioxide or bigger than ethanol. But these were huge molecules, but you could still apply the methods of physics to study them, and you could still study various aspects of them using chemistry. And I thought, this is just terrific. This is just what I want to do. And then I discovered that they were all in the same place, in the same new institute in Cambridge, in the Laboratory of Molecular Biology. They'd previously been in the physics department, that was Crick and Watson and Perutz, and in biochemistry in the case of Sanger. So all these Nobel laureates, all in the same building, all doing the sort of science I wanted to do. And I thought, well, there's just no dispute here. This is where I want to go to do a postdoc. So that's what happened. 3 days after my PhD viva in Swansea, and it was cemented actually by a chance visit to Swansea by a member of the staff of the LMB, Laboratory of Molecular Biology, Elin Rhys, who was a Welshman, and had a cottage in Gower and a family locally. And tragically, he died in an accident a few years later. But he gave a lecture on an enzyme, glycolytic enzymes, and studying active centers with chemical means. And I thought, well, that's it. That's what I want to do. So I secured an independent fellowship, which is a Bike Memorial Fellowship. And off I went 3 days after my viva. And I changed from being a chemist from a world of benzene and toluene and chloroform to a world of water.
You left the smelly stuff behind.
Very dangerous stuff behind. And I went to LMB, which is an absolutely wonderful place. And I worked in Elin Rhys's lab until I left to go onto the staff of biochemistry. Yeah.
Wow. It must have been, you know, you're talking about a sort of a subject that was evolving quite quickly, and quite dramatically at the time that you were there. I mean, you've named these people now that, you know, names that we kind of know about. It must have been an exciting time. Were you kind of aware of that excitement and that the fact that new things were being discovered in this field that was going to be so important moving forward?
Yeah, well, they already were important, and there was certainly that buzz around that. It's an amazing lab. There was a buzz about it, and there were people there who subsequently got Nobel Prizes. I mean, Sidney Brenner and Aaron Klug, who were there at the time, but all these people were just working away, and the atmosphere is very informal. Everybody talked about their work. The canteen is legendary. Everybody would have coffee, tea, and lunch in the canteen, and you could be sitting next to Max Perutz, or you could be sitting next to your cleaner, and this was how it was. So it was a wonderful, wonderful place. But this was still in the era of pre-recombinant DNA, so it's very different. The subjects changed beyond those amazing discoveries in molecular biology originally.
The names that you've all quoted then have all been men. How many women were there researching at the same time as you?
Hardly any on the scientific staff.
So it was just you then?
Well, I wasn't on the scientific staff. I was a fellow, and there were not very many research students there. I mean, now it's different, hardly any, but quite a few postdocs. But almost all of them were from the US or from Australia. And like me, they all had independent fellowships. They all brought money with them, and they were able to choose what they wanted to do, basically within the labs in which they were working. And many of those have gone on to do amazing things. It was a heady time.
A heady time, yes, indeed.
Yeah.
And it's fascinating. I'll come back and ask you about the actual workplace in a minute. But Tavi, your workplace, I guess, was on the ice somewhere in Greenland and the poles and that kind. What kind of environment was that to work in?
Well, yes, my lab is outside. My lab has been in various places in Svalbard, in Antarctica, in Greenland. So many of the expeditions that I've done, I've led. So that the advantage of that is you get to choose who goes. And many of the expeditions I've been on have actually been probably rather more mixed than is normal, without me really thinking about that at the time, but just I think that's true. But the first time I went to Antarctica, I was one woman in a field camp of 10, so there were 9 men and myself. But that has changed over time, and the most recent time, just the year before COVID, that I was in Antarctica, there were 12 of us and 3 women. So it's slowly getting better, but it's a hostile environment for parents, really, particularly Antarctica, because people go for, long periods of time, typically 3 months. And, that's very, very hard for people who have young children to go away for such a long period of time. So it does discriminate against particularly mothers of young children, I think, and it's more difficult for people to go into that environment if they have young children.
Yeah, and that kind of discrimination aside, did you ever feel that there was a certain amount of prejudice about you being there as a woman? Was there any time that you felt you had to fight for your own kind of, that I'm allowed to be here kind of thing?
No, actually, no, not at all.
No, I can imagine.
I mean, everyone takes different strengths into that kind of setting, or they wouldn't be there. That means different kinds of scientific strengths and different kinds of personal strengths. And in that kind of environment, you need lots of different kinds of qualities. You need the person that can make everyone laugh when it's the 10th day of storm and you're still sitting inside and you still can't get out and collect the data that you're all desperate to go out and collect, So that person's just as important as the person that can actually lift the boxes for longer than, other people. So everyone Absolutely. Brings themselves to that kind of trip. And the only thing that's really important is that people are working towards the same common goal together and to collect the data that you need. So no, I didn't ever feel that anyone was sort of saying, you're a woman, you shouldn't be here.
Yeah. And I suspect, thank you Tavi for that. And Hayley, are you okay? Have you got sound problems? I can hear the yeah. So what about your workplace? Because you've probably been to some fabulous locations, which is where they normally put these telescopes. So you've been allowed to go there, but maybe now it's more computer orientated, is it?
Yeah, that's right. So when I did my PhD, I basically spent lots of time on a mountaintop in Hawaii, which is lovely, taking data using the biggest telescopes that were there at the time. Now it's mostly you sit on a computer and you use a space telescope, and I say that as if it's a bad thing. It's not. The quality of the data from our space telescopes is so much better. Getting off the ground is so important for my kind of astronomy, because you don't want the atmosphere absorbing all your light from these galaxies, and you want to be as far away from the Earth as possible, because the Earth is itself an emitter in the infrared. So getting far away, getting these space telescopes are great, but you basically are just stuck looking at a computer, as it were. So I'm sorry, I did miss a little bit because of my headphones, my Bluetooth headphones stopped working.
Don't worry.
I wasn't sure if you were asking me about the sites.
Yeah, no, I was asking you really about the nature of your workplace, and I have asked Tavi because I guess that the field that you work in is quite male dominated. And have you felt any kind of prejudice in the work, or do you think things have changed now and that women are accepted equally in the roles?
So I have experienced significant prejudice and significant harassment as a postdoc and as a fellow and as a lecturer. Less so now that I'm a professor. I think people are a little bit more so on, but I talked to you about this before. I still remember walking into a work meeting just 2 years ago or so, and being asked where the coffee, whether I was bringing the coffee, and saying, actually, I'm chairing the meeting today. And it was really annoyed me a bit. Part of it is because I'm 5'2", I'm small, right? So that is part of it. And I don't look a lot younger than I am. Gosh, that's a big-headed thing to say. People tell me that they think I'm younger than I am. So that
you are, yeah, you do look younger than you are. Yeah.
So I understand that, but I'm going to be completely open. I've had men follow me at conferences. I've had men come into my door at conferences, assuming that, they have the right to do that. And I'm just junior when I was junior to them. I've had students, I've had colleagues who've been sexually harassed and physically harassed and discriminated again. I've had people say to me, well, there's no point in me applying for this job as a man because they just give it to any girl these days, or you only get that grant if you don't have any balls, or, it's all that sort of stuff. And I think it's a lot different now. I think for someone in my field, it is so rapidly becoming more female, not dominated, obviously, but they're more females at all levels. And when I was an undergraduate, there was not a female member of staff above a doctor in my university. And she was part-time, and then she left because of childcare, and she felt she couldn't do the work, so she left. So I felt like there wasn't anywhere for me to step into until, of course, you do see these women who are incredible. And that has changed. There are female professors, there are female heads of departments, there are female vice chancellors and pro vice chancellors. All of these positions, these leadership positions, have women in. And so that's fantastic now. So I do think it's changed. And I think the nature of the discrimination, certainly as I've got older, I've had less obvious discrimination and more micro kind of comments. Yeah. Like, I literally had emails when I was promoted saying you were only promoted because they had to put a woman in the position. And I just, and I had to justify to people, like, this is why I got promoted. And I remember saying to my other male colleagues who got promoted the same round as me, who had exactly the same big grant that I had, right? And not one person, not a single person in the department said anything to them about why they were promoted, not even asked them. I had people at my door saying, well, I don't think you're ready yet, because, so they must have done it to fill some quota to get women in. And it's those microaggressions that I'm just really kind of sick of now.
Yeah,
But,
it's so annoying. But
oh, it's so annoying.
what do you tell your students, your female students coming up after you about that? Because, you know, what you're saying resonates with why you were a fan of Vera Rubin, because that's something that she went through, isn't it? So how are you kind of passing the advice on, or has it changed enough not to be so concerned about it now?
I think it's changed a lot, but I hate it, but I have to have a conversation with my female students about conferences. And if I'm not with them, or if a senior member of my team isn't with them, then there is a conversation about, look, you know, watch out for these people. It's awful to do, but it is there. And also, don't be alone, keep together in groups. You know, it's also the sort of thing of, some of them don't have any of these issues happening to them, and some of them do. So there's also that thing of, be aware that, you know, you've got to be tough. You've got to be tough. You've got to. And I think that's a good lesson in all walks of life, not just for science, but, you know, be tough, be driven, push your way through. Don't let anybody tell you what you can and can't do. And don't let anybody don't compare yourself to somebody else, so much so that you end up not being able to do anything because you've you think you're not as good as you are. And so I just tell them to do those things, but also to be really careful and to think about the fact that, you know, if anybody says you can't do it, just, you know what, they're not worth your time. Just move on. You know,
I can see Tavi smiling there. You would say the same.
Yeah, you just whatever.
Well, totally. I'm wondering a little bit whether I have failed my PhD students. I think I treat both men and women in the same way, which is, I'm just feel it's my responsibility as a supervisor to make sure that they get the job that they want, whether that is in academia or not. And I feel it's that's my role, so that not only that they should get a PhD, that's kind of, you know, the first tick, but that they should leave going to a job that they're really excited about and that they really, really want. And I haven't sort of done special things for the women compared with the men, but I think I've facilitated things for all of my PhD students regardless, given them every single opportunity that was possible regardless. So I'm wondering whether I've failed in some way to warn students about things, but I feel like
I think genuinely different fields are different. There is an issue in astronomy. There are some very high profile cases of you know, very senior people having, you know, effectively lost their jobs for sexual harassment. So there is an issue with astronomy in some cases. But not only that, I think, you know, my male PhD students, I mean, I don't do special things for my females, but I don't have the conversation with my male students to be careful. I do have the conversation to them that they also need to be respectful and maybe think about my postdocs, think about what it looks like if they're following around female PhD students, you know, why are you doing that sort of thing? They don't, but, you know, just to have a conversation about it. Because it is scary when you are a young female PhD student and a senior man follows you to your hotel room. And that has happened, right? And that is an issue. So I think different communities are different. I'm making astronomy sound terrible. These are very small numbers. Different communities are different. And I think it depends on the department you work in as well. If your department is about working together, your field is about working together to get an answer, that's great. But there's some fields in physics that are just so snipey, and that translates to, you know, kind of a bitchiness about discussing things, you know, like unprofessionalism, I guess.
I think that's what's important, though, isn't it? Moving forward to talk to young women about the possibilities of doing science, because, you know, Hayley, you were talking about sort of the experience of being in a boys' school as sort of like, you know, one in a couple of girls, and you know, a lot of girls have felt that over the years, that they have sort of felt that they have to prove themselves far more than other people have to in order to justify their place. And I did read about the stuff that you're talking about in astronomy on the web. It's there for people to read if they want to go for it. But I wondered, Jean, your workplace is a kind of laboratory. You know, you're there in your lab coat and in your corner with your experiments. Do you think that maybe the kind of subject that biochemistry or even chemistry is, that you can just get on and focus with what you're doing, and maybe you don't have as many relationships with the actual team other than your own little group?
Oh, I think, well, no, I mean, it's a group effort, but, you know, individuals obviously have jobs to do, but biochemists go to conferences quite a long way away. And, but I personally, I have not, maybe I'm just too old, because I'm old enough to be Haley's grandmother, no, mother anyway. I didn't suffer, I haven't suffered any, as far as I know. I may have been very naive or just had my head down, but I haven't suffered discrimination, and I haven't suffered any undue harassment above the sort of normal base level. I've always worked, apart from the girls' school, when in my chemistry class, I think there were 3 women in the honours class, which I dug out a photo recently and looked at it. There were just 3 women. When I became a research student in Swansea, there was only 1 other woman. So I was one of 2, all the rest were men in the department. There were no female members of staff at all. When I went to LMB, there were 2 or 3 female staff members. Some of the postdocs were definitely female, so that was fine. When I went to biochemistry, I became the 2nd woman on the staff. There was 1 other. So there were 2 of us for about 10 years. Then Alison retired, and I was the only one. And now there are 4 or 5, more than that actually, there's a good number of women. But in those days, it's a big department. There were only 3 professors. Now there are something like 15 professors. So all sorts of things have changed over 50 years. You know, world's a different place over 50 years.
Yes, well, I mean, that's the point, isn't it? I think everything is changing and evolving, and it was, you know, I think for many girls, I think it's good to hear all of these kind of attitudes to the subject.
But I'd say, as Tavi said, that I wasn't aware at the time that I was only one of 3. I could have counted, but I didn't put things on my consciousness. I didn't really realize the significance of being one of 2 research students. I didn't even realize that, you know, being the 2nd member of staff was female meant anything. But the odd thing is, in biochemistry, in generations before, in the early 20th century, there were women. I mean, there were women who were doing great things in biochemistry. One of the earliest FRSs was Marjorie Stevenson. And, you know, she was a woman. So something's happened, that women sort of went out of fashion and then they've come back in again.
Yeah, no, I think you're right. I do think you're right. Maybe it was just a novelty when you were there, you know, and it's kind of turned. But anyway, thank you for being prepared to talk about that, because I really do think that it's good to get it out there, because I think it should be discussed. But Haley, can I come back to you, because you you know, you must have some highlight moments in your career, but things that you've discovered. I mean, that cosmic dust thing is fascinating. What would you say are the things that have really made you want to celebrate in terms of what you've discovered?
Yeah, I guess I was a PhD student working with Mike Edmonds at Cardiff, and he has this kind of very simple set of equations, and by simple I mean they're A-level simple. They're not complicated maths, which very roughly describe how all of the elements evolve over time in a galaxy. So this huge system of billions of stars, and you've got gas, and you've got dust, and you've got stars, and you've got heavy elements from the periodic table, and you can just follow how they evolve over time using 3 equations that are 1 line each, and they're really simple. And what he said was, oh, you know, all of my equations fit everything and they're really great. It's like, oh, great, this is really special. And I thought, well, I'll just put them in a computer and see where they don't work, see where they fail, maybe. And from doing that, we realized that his equations were assumptions, and they only worked over a certain kind of regime. And then if you took that assumption out, And the assumption was that everything came out of stars in one go, which we know is not true, that stars form and they eject material and then they die and then they carry on and new stars form. When we took the time assumption out, we realized that you couldn't explain any of the dust that you see in galaxies maybe a few 100 million years after the Big Bang. So you saw all this dust using telescopes, but you couldn't explain it theoretically from stars. And I think it's my most highly cited paper still, my PhD paper, but it's also just really simple. It's just 8 pages and it's just, you know, here's some equations, and if you look at the assumptions into them, they break. And I love the simplicity of that. And we also pointed a telescope at a supernova remnant. This is a remnant of an exploding star. And everybody was telling us, don't bother, you're wasting your time. There's no way a star that's blown up could ever form dust and it would survive in that environment. This is million-degree gas. There's no way. Dust would just evaporate and it wouldn't be there. It can go on to make planets and so on. And we pointed with Loretta Dunn actually led this, who was working with me at the time. We pointed the telescope on Hawaii at this one exploding star that blew up 400 years ago. And we took a photograph in the infrared and we downloaded it. And it was like, oh my God, there's loads of dust there. There's enough dust to make 100,000 Earths worth of planets. Yeah. And that was published in Nature, and it was just the real highlight, really, of what I've done. Just taking a picture and seeing it arrive on your computer and going, oh.
So how did you celebrate, Hayley?
Well, we were up on a mountain and we only had about 60% oxygen in our brains, so we were pretty giddy about it. But yeah, I think we went down and had a huge breakfast at the halfway house on the mountain, and then slept all day.
Yeah, I can imagine. I can imagine. And Tavi, you know, the stuff that you've been doing with the ice, what has it made you feel? I mean, what kind of work have you done to contribute to our knowledge of how climate change and global warming is actually going to impinge on us? I mean, whereas Hayley could celebrate, I mean, I'm wondering whether actually your work actually leads to thinking, oh no.
Well, I'll start on a slightly more cheery point than answering that question directly, which is one of my sort of 2 highlights of science, those eureka moments of your career, came from an experiment that somebody at the sort of startup meeting for these grants said, I don't know why you're doing that. There's no point doing that. You won't learn anything new. It's already been done. So we were putting GPS sensors out on the front of a tidewater glacier in Greenland. They were going to be wirelessly linked back to the mountainsides at very high frequency. And this particular person couldn't see what on earth was the point. This had all been done before. And we discovered something really exciting and really new doing it. And basically that as an iceberg is carved from the front of one of these big glaciers, that momentarily the glacier stops moving and actually rebounds uphill. So, you know, if you'd asked me before we made those measurements, if you could do anything that would stop one of these big glaciers moving with gravity downslope continuously, I would have said, no, you can kind of slow it down or speed it up, but no, I can't see any way that you would actually reverse the flow. We found that these big icebergs, as they come off when they backward rotate, the glacier ice is actually rebounds and is forced backwards and causes these glacial earthquakes. And it was just Hayley's story there made me smile in memory that somebody else had told me that there was no point doing something, and it led to a science paper. And it's kind of one of those things you go, I'm smiling there. But for me, there's sort of those highlights always come from spotting patterns that I'm not expecting. So I remember the explanation for what was happening there came to me sort of, I was sitting in a conference presentation and somebody was making a presentation about something sort of related, but not really related. And I just sort of went, that's what we're seeing. I know that. I've seen that somewhere else. And that's happened to me a number of times in my career, those sort of real spots of patterns, things that I suddenly understand how it all works. And that's what makes it all, you know, for me, those are the highlight moments, is spotting very, very unexpected patterns and bringing them back into my own work. But you asked whether the prognosis is all sort of depressing. And I think my eyes and the eyes of many of my students, both undergraduates and graduate students, will be focused on what happens in Glasgow, if Glasgow actually goes ahead, and what we manage to achieve as a political world, in terms of curbing our global emissions of greenhouse gases. So I think there'll be a lot of people whose lives I've touched in various ways by teaching them about climate change, who will be looking very closely to see what happens there.
Absolutely, yeah, thank you. And I'm sure that you've had some pretty special moments, Jean, over the years, in those eureka moments. But first, I wanted to ask you if you would talk about something you did mention to me about. Not that I'm saying that you go back a long way, but you do go back to bucket chemistry. And you were talking about the kinds of things that you had to do to get your samples back in the day.
That is true. I mean, for the layman, now if students want to study proteins, properties of proteins in the lab, they will not go and extract it from an animal or from a plant or from a bacterium. What they will do is they will look at its sequence and they will clone the gene for it. They will, using recombinant DNA technology, which is only introduced in the mid-70s, they will put that gene into bacteria or similar cells, and the bacteria, which can be then scaled up, will generate large quantities of this protein for them, which they just have to purify. So that's recombinant proteins with late 70s and recombinant DNA early 70s. Before that, all the enzymology that was done, all that had been done back a century before, was on the bucket scale. If you wanted an enzyme from liver, you would have to go and get a liver. It might be from a mouse, or it might be, if you wanted more, might be from a cow or a pig. You'd have to go to the slaughterhouse and you'd have to mash it all up and remove the garbage and then extract the proteins and then fractionate them. And there were hundreds of them in there. And you might end up with a tiny amount of pure protein. That was called bucket chemistry, because it's quite often, early stages were done in buckets. They were done in buckets. And when I worked on the enzyme at LMB, which is a glycolytic enzyme, but a particularly good source of that, which had been identified by Ian Harris, was lobster. And we had lobsters every time you wanted to do a prep. And from the tail, the back muscles, we would extract the enzyme, and then the claws we would keep and cook and make lobster salad from. So that worked out pretty well. That was on a large scale. On the histones, when we wanted to prepare histones to combine with DNA to assemble chromatin in vitro, then the histones came, the particularly rich source was calf thymus. So that meant a visit to the slaughterhouse to get thymuses from calves. And when I worked later on inactive chromatin, a good source of that was red blood cells from chickens. And while the early days, you could go to the farmer and say, if you're killing a chicken, could you give me the blood and I'll turn it into molecules, basically, which is all I was really interested in. But later on, well, all the restrictions and everything that were put in place, you had to go to the slaughterhouse, which is in Bury St Edmunds, and give them a receptacle in which you'd put an anticoagulant and ask them to fill it with blood and drive it all the way back to Cambridge. And then collect the red cells, wash them, lyse them, and get them down to a nice white pellet, small white pellet, which is the nuclei, and then digest that and release the lovely chromatin and the molecules that you want inside. All the nasty stuff is out of the way. So to see that, you know, in a lifetime, now it's recombinant, everything's recombinant. And if you want proteins for crystallography and NMR spectroscopy and so on, you can get them in a much purer form by expressing them as recombinant proteins and larger.
Sorry, do you think, would you have preferred to have been working at a time when you could do the recombinant stuff as opposed to the bucket stuff, or was there something really exciting about that, you know, that necessity of getting the real thing to be able to work on?
Well, it had its place, but you know, I changed from the 1970s when the new technology was available. Then I started using that. So in later years, all our proteins for structural work have been made by recombinant DNA technology.
And what about your eureka moments then, you know, with the tetramers and, you know, tell us a little bit about that.
One was very early on. I mean, there have been mini ones after that, but to just mention one, because I think we're running out of time, is what I'd mentioned, the packaging of DNA and the complexes of proteins. It was when I showed that the histones is the protein, the positively charged proteins that package the negatively charged DNA and neutralize the charge on the DNA and allow it to be collapsed. Otherwise it would repel itself and stretch out. Were well-behaved complexes rather than nasty aggregates, which they'd previously been assumed to be. And this is because they'd been prepared by much gentler methods. And seeing on a gel, you never actually see the proteins. Of seeing a band by gel electrophoresis after I'd used the techniques that I'd previously used on enzymes, cross-linking techniques, showing that a particular fraction consisted of a tetramer and another fraction consisted of a dimer, and these were well-behaved molecules. That was something that was not known before, and that information was crucial in elucidating the beads on a string structure of chromatin, which is where you have spools of protein, which are octameric, 8 protein chains, with the DNA wrapped around them and then onto the next bead and then onto the next bead, the DNA on the outside. Whereas previous models based on ideas about aggregated proteins had the DNA on the inside of something that looked like a telephone wire. So the DNA would be on the inside and the proteins, the histones, on the outside, the insulation. And that didn't explain very much because the DNA was all inaccessible. But when the DNA is on the outside, it can become accessible. And when it's quantized in these repeating subunits, then it changes the whole picture. So my eureka moment was seeing that first gel where I knew that was a tetramer, and that was just mind-blowing.
And how did you celebrate?
I don't think we did celebrate, actually. I think I made a phone call to the person I was collaborating with, Roger Kornberg, and said, if you want to see this gel, you better get down here now, which was 2 miles away. And he was down in record time. And it was amazing. And that gel sort of was on my wall for ages.
Wow.
Picture.
And of course, he went on to win the Nobel Prize, and you don't have to answer this at all or make any mention, but I have a sneaky feeling that an awful lot of that happened because of the data that you collected in advance for him on the packaging of the DNA.
No, that's, as I told you before, Elin, that isn't correct.
I know, I think your modesty is huge.
The Nobel Prize was for RNA
transcription, yeah.
Get the Nobel Prize for transcription, not as you read in Wikipedia, transcription and translation, but it's just for transcription, and it was not for chromatin.
I still say that you helped, Jean. And I leave it at that. But Hayley, coming to you, and it's interesting, isn't it? Because I think that your work on the cosmic dust actually provides Dame Jean with her molecules for looking at the body, because your belief is that cosmic dust is what formed the molecules of life on this planet. Is that so?
Well, yeah. So cosmic dust is just a loose term that we give to small particles. So these are nanometers in size. So they're actually bigger than the things that Jean looks at, up to microns, actually, up to a couple of microns. So these are just solid lumps of, it can be carbon, silicates, gems, just basically solid material. So a lot of it in galaxies is kind of soot-like. So that's why we can't see much of the exciting things in galaxies, because it's almost like there's a cloud of soot around the stars. So when we talk about it being the building blocks of life, it's certainly these dust aggregate together to get a rocky planet like the Earth. But we also know that we're kind of part solid, right? So we also have some of those materials in us. But I think what I look at is quite a bit bigger than what Dame Jean does. Yeah.
Before I ask Tavi my next question, and we are due to be off the air, as they say, at 5:30. So if anybody wants to ask any questions, please do that in the chat. There's plenty more that I can ask. But if there is anything that you want to ask, there's a thing at the bottom of the screen, Q&A, and I think that is where you put your questions in. So do that if you want to. But Tavi, given everything that you've done and looking at the students that are coming up behind, what do you think are the personality traits or the characteristics that you have that have enabled you to do the research and that you think that young people coming into your field of work really need to have?
Well, I think if you want to be a field glaciologist, you better like being outside. And you better like being outside in places that, aren't as comfortable as living in Swansea or in Wales. So yes, I mean, there are plenty of glaciologists who make enormous contributions, probably the biggest contributions, who are working on computers or remote sensing mainly, and aren't getting out there in the cold, sometimes in the dark and so on. But I've done some extraordinary things in the field and been really, really privileged to be able to be in environments that basically most people never get to dream about visiting. Some of them people can go to if they pay enormous sums of money as tourists, or they might get to sort of feel like they're going to Antarctica, but they don't get to live, for 3 months in deep field, 3 or 4 plane hops from the nearest base in the way that we do. So I think you need some resilience. I think you need some determination. I think you probably need some physical robustness, to be honest. And I think you just have to be somebody who loves being in beautiful environments. I mean, the places where I work are incredibly privileged to be able to be there and to see them over periods of time. So it's very, very special to me to go somewhere and be there for 2 weeks, for 3 weeks, for 2 months, for 3 months, and watch it change with the seasons, change with the weather, the good weather, the bad weather. I've sat in a tent in Antarctica for probably nearly a month with repeated snowstorms, periodically digging out things as it stopped and hoping that was the end, but no, the snow comes back. And just having the willingness and the persistence to assume that eventually the weather will be good enough to let you do what you need to do. So I think an appreciation of beautiful places is really helpful. Quite a lot of determination, quite a lot of grit, persistence, and a willingness to do it, to just try. And if it doesn't work the first time, then to go back and try again until it does work. So
persistence is a good word. And of course, kayaking is one of your things as well, isn't it? When you're not sort of doing your work, you can be found off the coast of Mumble somewhere in a kayak.
Well, yeah, I really do love being outside, and I really do love the natural environment. And I think if I wasn't a glaciologist, then I could probably be an oceanographer. That would be my second career will be in that. I've been lucky enough to be able to sort of almost combine them by working quite a lot on small boats off Greenland. So been on a small fishing boat for several summers, proceeding along the coast of Greenland at basically walking pace, so roughly the same pace that we kayak, but collecting data over the side. But yes, I love kayaking. I love the natural environment around Wales. We have an incredibly special coast. The possibility of seeing porpoises and dolphins is always amazing. Occasionally sunfish and things like this. It's just beautiful. I haven't yet seen Wally the walrus, the new resident of Tenby, but maybe that will happen too.
You've probably seen enough of them in your time.
Well, actually, no. So walruses I haven't seen. I've seen polar bears and I've seen penguins, both in their natural environment. In field camps, we're more likely to see polar bears in the north. Where I work in the south is too far from the coast for there to be any real life there at all. Real sort of large life, birds or whatever. But no, I haven't seen Morris's in a while.
Oh, right.
And I haven't seen a narwhal either. So I have to keep going back to the Arctic until I've at least seen a narwhal.
So there are things to do.
Yeah.
Haley, I think that Tavi is doing a really good job of selling her subject here now in terms of what it's like. But you've just had adopted twins, beautiful twins. I think you said that they were 3 years old. So that will obviously have changed your life, but you can still carry on with your research. But are there things that you're going to have to adapt? Because maybe going to Hawaii at the moment anyway won't be able to happen.
Yeah, it's something that I hadn't really appreciated. I just kind of thought, well, people have children, right? So, and then they still work and they still do their jobs. But I didn't factor in the fact that when kids are young, they get ill a lot. So I've actually had to pull out of a conference for an invited talk because my little girl was ill, which is a real shame. And that was in a lovely place in Crete, which would have been just so beautiful. But yeah, I have definitely found that I have to pick and choose what I can do, and there are fewer hours. I used to work very long hours because I love research and I love teaching. I don't like all the admin things. Nobody likes all the admin things, but you know, you work long hours because you love it. We are privileged to do what we do, and we really, you know, I love kind of doing my work, and I can't do that anymore. I can't work those hours, not only because there's two little things just like crawling all over me all day, but they need to be fed and watered, and they need to be taken to school, and it is school holidays and so on. It's just different. So what I'm trying to do is, pandemic aside, obviously, because that's been a whole other challenge, I'm just trying to be very focused on what I do and prioritize what I want to do. But yeah, it's changed things. Yeah. It really has. But I will say I totally agree with everything that was just said about personality traits. You know, whatever science you do, I think the perseverance side of things, you've got to be able to try and try and try. And if you fail, learn something from it and try again. And you just got to try not to be scared of not knowing things, because you're not going to know a lot of things. Just try and find out as much as you can and see where you go with it. I think just perseverance is the word, I think.
And I can see that Jean is agreeing with you there, because, you know, and there's a question come in actually, Jean, which leads me to what I wanted to talk to you about next, because obviously perseverance in your subject, there's a time comes, and it came for you, when you actually weren't allowed to carry on with the research. You had to shut your lab down, even though there were probably lots of things you still wanted to do, but you did go on to be Master at St Catherine's, and you're in a leadership role, if you like. And the question has come in asking you, you know, what advice would you give to inspire scientists like yourself to move into those leadership roles?
Right, well, it depends on what leadership role, of course. I can only speak from my own experience, and I think it's a very personal thing. Different people do things different ways. I did nothing but research and teaching for the first 15 years of my career. I taught for the whole of the rest of the 45 years that I spent on the academic staff. But in the 80s, I started out in my first post in Cambridge was in 1969. So by 1980s, I was getting asked to sit on committees and do things outside. These were national committees. And so I took on quite a lot of jobs on research councils and research council panels, on the grounds that I think there are three strands to an academic life. There's research, there's teaching, and then there's service, which is putting back into the community. And this means serving on grants panels. It's not admin as such, but it means helping other people's work get recognized, reviewing papers, which we all do, reviewing grants. And this was, you know, this would extend the day by hours. This would reduce sleeping time considerably. And one job led on to another. I was on the council of the Lister Institute and then the Imperial Cancer Research Fund. And then the Wellcome Trust, I'd sat on their panels and I became a governor of the Wellcome Trust. And that's a major funder in the biosciences with a spend of about 900 million or more per annum. And what you get to see by doing jobs like that is the whole breadth of biosciences, so nationally and internationally as well, at a very high level. And that is deeply absorbing and very rewarding. I served on Royal Society committees after I was elected, and then I became the biological secretary and the vice president in, I can't remember when it was, for 5 years. And that again gave me exposure to a breadth of, although I was responsible for the biological sciences, gave me exposure to everything from climatology and cosmology and to batteries and pure maths and string theory, but hear talks and look at people's election documents. That's very educational. Yeah. But you've got to get some pleasure out of these things, otherwise there's no point in doing them.
And then, indeed, sorry to cut across you, but the question is actually asking as well,
right?
What advice to women would you give in those leadership roles? I don't know whether the question is asking whether there's a difference, but there are fewer women, aren't there, who will go on to these leadership roles. So what would you say to them?
Well, I don't know if I'd call these leadership roles, but it's take opportunities as they arise. These were jobs that arose. I didn't say yes to everything by any means. I suffered throughout my life and still do from imposter syndrome. So I always assumed when I was asked to do things that I just wouldn't be able to do them. And then the further along I got, the more I realized that I thought that last time and it worked out all right. And so even though I felt uncertain that I might be able to make a go of it, I thought I would give it my best shot, and it usually worked out well. So what advice would I give to women? Well, I think to look at opportunities as they come up, be prepared to work hard. I mean, we're not talking about 9 to 5 existence if you want to take on extra duties, and they cannot cut into research time and teaching time. You have to do that. So something else has to go, and you don't have a lot of spare time.
And I think you've hit the nail on the head. And one thing that a trait that often women have is assuming they can't do something, that they've got imposter syndrome. So the first rule is not to believe yourself when you've got imposter syndrome.
It's impossible not to believe yourself.
But do it anyway. Is it feel the fear and do it anyway?
But some of these opportunities, like the ones I've mentioned, but also I was involved with the British Museum as a trustee for 10 years. Now, people ask me, what are my hobbies? Well, apart from music, reading and walking, I don't have any exotic hobbies, but I got tremendous pleasure out of things like the British Museum, where you're exposed to the breadth of the collections, you get deeply into it. So I've spent a lot of my time that I might have spent on, I don't know, some exotic hobby, doing things like that instead. So what advice would I give? Be prepared to, if you want to take on extra jobs, then be prepared to give up some other things, but make sure you're going to enjoy the job that you're doing. There's no point in not enjoying it. And you're going to need all the qualities that we've heard about already that are needed for working in the lab to keep all these balls up in the air and, to keep yourself being sane, actually, at the end of it all.
Yes.
But it can be very rewarding if you do it.
Thank you very much. Well, we're nearly at the end of our talk, but I wanted to ask everybody if you could answer maybe briefly in a kind of one-word answer. Well, no, one-sentence answer. Is looking at the world today, right, and what we are going through in all sorts of different things. And you chose your fields because of the impulses and of course the situation at the time. Is there anything that if you were starting over now, what kind of field do you think that you would go into? Would it be the same or might it be different? Hayley. Thought I'd end on an easy one.
First.
Sorry.
Do you know, I love my subject and I love everything about astronomy. So I could imagine doing everything in astronomy. Not that like Jean, I also have imposter syndrome. quite significantly. So I also feel like I couldn't do any of those things, but I would love to try. I really think I would probably go into climate science somehow, or I don't know whether I would be as inspired as I am with the astronomical side, but I really would like to make more of a difference. And I think climate science is one where it's so important now that, you know, I think I would like to contribute in that way. So I think I would change my field, and then astronomy would be my hobby.
Yeah, interesting. Thank you. Tavi, how about you?
Well, I'm going to turn that back at Haley and say I think that anyone choosing the field of study should choose what they love, what they're fascinated by, what they're driven by, because that is where, you know, you are going to make the most difference, because if you love it, you will do it really well and passionately. I mean, it's interesting she said climate science, and I think I would do the same field again. However, I would also say that my field has changed. When I came into it, I think glaciers were kind of interesting, but a bit of a sort of something that, you know, was a bit unusual to be interested in. And it's become a kind of a field where, you know, governments are interested in how much sea level rise there's going to be, and suddenly it's become important at governmental level. So I think I would also say that being a climate scientist doesn't necessarily mean that you feel you are changing things. I feel a bit like through my career, I've stood on a mountainside waving a flag, a bigger and bigger flag, and shouting louder and louder, look what's happening, and things haven't changed. So I think I would also say that I think scientists have responsibility to get involved in how we actually use the science results that we get. And I think that's really important, that we don't forget that scientists are people. So scientists do have a responsibility to get involved in things like policy and so on. You know, it is important that we have scientifically literate people helping make the decisions about how we live. So I would say do the science, but also get involved in your community or in society or whatever it is that where you feel that you can make a contribution.
Thank you. And it's interesting because I was having a sneaky peek at the participant list, and there's lots of people from the Welsh Government that are listening in to this conversation. And I think you'd possibly want to give that message to them too, to support the scientists working in Wales today. And finishing with you, Jean, Dame Jean Thomas, what would you do if you were starting again?
Well, I still have a passion for biosciences, so I would, like Tavi, I would stick with the biosciences, but possibly move more into the biomedical area. There have been so many advances in genomics and so on, and new ways of being able to explore the depths of disease. I think experimental medicine, it would be interesting to wonder whether I would train as a doctor, but I think I would be one of these clinician scientists, academic medicine people who don't spend all their time with patients, but spend a large part of their time in the lab, but seeing patients for part of the time, but mainly doing high quality research. That would be very appealing, actually.
Well, thank you so much. I think the couple of things that have struck me is how you all want to make a difference, and that's what science can do, let's face it, is making difference in people's lives, and that anybody thinking of starting up science today, there are so many opportunities there for doing worthwhile things. And the other thing I think is that it's this confidence issue for women also, that we shouldn't have that imposter syndrome, because I can guarantee you now that not one of you is an imposter and that you are the genuine real deal. And I'm very, very honoured to have carried out this conversation, and we are very, very lucky in Wales to have you. And you are excellent choices for the Frances Hoggan Medal, which brings me to tell you all that there will be a new recipient of the Frances Hoggan Medal. And I think that's been announced at the end of May. So do listen out for that latest winner. And of course, I'm sure that many of you watching will know of women that really, really deserve to have this accolade. So please, ready now for 2022, do go out there and nominate women that we know deserve this. I think the more of this it is done, the better for us as a nation, because I think we've got a lot going for us. We may be a small nation, but we really do punch well above our weight. So diolch yn fawr iawn I chi I gyd am ymuno, mae hi wedi bod yn bleser. Thank you all three, but I hope you've enjoyed. And hopefully one day we can all meet and share the same air and actually talk together, which would be absolutely lovely and a real privilege. Diolch yn fawr iawn I chi gyd. Thank you.
Diolch, Elin.
Bleser.
Diolch. Diolch yn fawr.
Yeah, thank you, diolch.